What's up guys, welcome back to the channel. In this particular video I will explain the problem remove duplicate element from sorted linked list. Now this problem includes a very important concept of linked list guys, so make sure you stay tuned till the end of the video. At last you will have complete idea about how this problem can be solved easily. So starting with the problem statement, it says that you are given a single linked list consisting of n nodes. Your task is to remove duplicates from the given list if exist. Okay, now one example is given here guys. Let me explain this particular example. So we have a linked list that contains four elements. We have 2, then again 2, then 4 and then 5. And you can easily notice one thing, that this list contains duplicate elements, right? Our task is to remove them. So when I remove the duplicate which is present here, so I will have 2, then 4, then 5, and this particular list is going to be the output for this particular example. Now guys, this is about the problem statement. Let's discuss the solution now. Okay, so I have written one example here guys, and see, the approach is quite simple. We are going to traverse the list from left to right, and while traversing we are going to pick every unique element and create a linked list out of it. What does this mean? Let me explain with the try run guys. So I'll start from this particular element, and currently okay, let me name a pointer. So I have a head pointer, right, which is given in the function itself. So I have a head pointer, and this is going to point to every particular element in this list. First, head pointer is pointing to this element. I will pick this node and I will add it to the answer. After this I will come, okay, let me name it answer list guys. Let me name it answer list. So initially answer list has this particular value, and now guys my head will move. My head will now point to this particular value, and you can see that this value which is being pointed by head and the value which is being pointed by last element of the answer. So let's say we have a answer pointer guys, these two value are same, right? So I can't simply append the new node to the end of this particular list. This is going to create duplicate nodes in the answer list. So we will simply move without adding the list guys, without adding this particular element to the list. So how to write this condition? So I have answer pointer, right? I will simply check condition, if my head data is not equal to pointer data, right? Pointer data, in that particular case only we are going to add the element, but this condition is not true for that particular case, so we simply moved without adding the element guys. After this, now again you can see that this is pointing to 2, right, and answer point is pointing to 1. So now we have different elements, so in that particular case we need to add element. How we add? I will simply say that, okay, whatever is this pointer, I will say pointer dot add. Okay, pointer dot add. Actually, I should write pointer dot next, right? So I'll write pointer dot next is now equal to head, right? This way, I will have this pointer dot next pointing to this element which is 2, and after this I will simply move this pointer to this particular element because I want my pointer to point to last element every time I add any new element. So I'll write pointer equal to uh, pointer dot next. This is what we are doing guys, this is the approach that we are following. After this my head will come here, and again you can see that we have a different element, so this condition will become true and I will have 5 here, and now pointer is pointing to this particular element. Similarly, I will move here, and again you can see that this condition is not true. Now we have head dot data which is equal to pointer data, so condition is not true. I'll simply move without adding. After this again condition is not true, so I'll simply come here, and then I will again see 9 here, right? And now you can see that 9 is something which is not equal to 5, so I can simply add 9 here by doing these particular set of operations. Now my pointer is pointing here to 9, right? This is the last element of the answer list. Now after this I will come here, and you can see that I have 11 here, right? So I'll simply okay, this 11 is not equal to this 9, so I'll simply add 11 here. But when I make this particular thing like pointer dot next equal to head, then I have not broken down this particular link. The link is also there, right? This particular link is also there. So guys, when this particular loop completes, we have to do one step. We have to make pointer dot next equals to null, right? So that this particular link breaks, because now my pointer is pointing to this particular element and I want my last element to point to null. This is how linked list works. This is what is linked list. We have always last pointer which is pointing to null value. So now our task is done. from this list we have every unique element present in this particular list, guys. So this is how we can segregate every element, every unique element from the list, and now every duplicate is removed, right? So I can write this particular thing while my head is not equal to null. My head is not equal to null. I will keep running this particular loop. And okay, let me improve the code, guys. What I'll do is every time we will do head equals to head dot next, right? So I'll write here head equals to head dot next. This is what we will do inside the loop, and after this at last we will do pointer dot next equals to null. This is the approach that guys we need to follow in order to get every unique element in the answer list, right? And what about the time and space complexity? So see guys, time complexity for this approach is not more than O of n, because we are traversing the given linked list only. And talking about the space complexity, so it is O of 1, guys, because we are not using any extra space. You can see that when we do this particular thing, so we are not creating a new node, we are manipulating those nodes only. So what we do is when we say answer dot next, answer pointer dot next equal to head, so actually I'm creating a link. I'm only manipulating the link. I'm not guys like I'm not creating any new node, right? So that's why the space complexity is O of n. Now this is about this particular problem, guys. Let me show you the code. Okay, so this is the code, guys. You can see that what we are actually doing is we are first creating a answer node. Okay, why we need to create a answer node with value -1? Because guys, initially we want our answer pointer to point to any value, right? To point to any node. Like if our answer is null, so we can't make an answer pointer which is pointing to null value, because this is not the case. What we need to do is we need to make a dummy value, and then this pointer is going to point to that particular dummy value, so that we can move the pointer, right? Because if we make the answer equal to null, let me explain, guys. So if you make answer equals to null and this pointer point to this null value, so we can't do this particular step because null doesn't have any next, right? So we need a dummy node so that we can get this particular next, and we can do this particular step every time. So that's why we initialize our answer with a dummy node which is -1. So after this we have a simple step which is we are initializing answer pointer here, and then we are moving our head pointer till it's not equal to null, and only if this condition is true we are adding the value to the answer, right? So that we can have only unique values added to the list. So guys, this is all about this video. This particular concept is widely used in different type of like linked list problems, so make sure you do some more problems based on this particular concept, guys. Like we have a problem which is segregate uh, even and odd list. This is again a very popular problem of linked list, guys. So make sure you do every problem related to this particular concept, because this concept is one of the important concept in linked list. This is all about this video. Thank you.